Right now, at this very moment, a galaxy twice as massive as the Milky Way is moving directly toward us. It's already so close that we can see it with our naked eye on a clear night. It's called Andromeda, and in about 4.5 billion years, it's going to crash directly into our galaxy in the most catastrophic collision the universe has ever witnessed. When it happens, the impact will be so violent, so destructive, that it will fundamentally reshape not just our galaxy, but everything about our place in the universe. Stars will be ripped from their orbits, planets will be torn from their stars. The Sun itself, the star that gave birth to life on Earth, the star that has governed our world for 4.6 billion years, might be ejected into the cold void of space, leaving Earth frozen and dark forever. Most people have no idea this is coming. Most scientists spend their entire careers without really thinking about it. But when astronomers started modeling what would happen, they discovered something shocking. The collision is so far away that we think we're safe, but we're not. What Andromeda will do to our solar system is far stranger, far more dangerous, and far more inevitable than anyone ever imagined. By the end of this video, you're going to understand exactly what happens when two galaxies collide. You're going to understand the forces involved. You're going to understand why our solar system might not survive what's coming. And you're going to understand that we are living on borrowed time in a universe that changes in ways we can barely comprehend. If you love exploring the deepest mysteries of space, the biggest challenges facing humanity, and the fate of our world, then this is the video you need to watch right now. But before we dive into this cosmic catastrophe, if you enjoy space documentaries, astronomy explained, and videos about the future of Earth, please like this video and subscribe. It takes just 1 second, but it helps this channel reach more people who want to understand the cosmos. Now let's begin. The year is 4.5 billion years in the future. To understand how far away that is, consider this. Humans have existed for about 300,000 years. That's the entire span of human existence. Now imagine that time repeating. Not twice, not 10 times, not 100 times. Imagine that tiny span of human history repeating 15,000 times over. That's how far in the future Andromeda's collision with the Milky Way actually is. It's incomprehensibly distant. It's so far away that it seems irrelevant. It seems like something that will never actually happen. It seems like ancient science fiction. But it's not fiction. It's physics. It's gravity. It's the inevitable consequence of the way the universe works, and it's already in motion. Right now, as you're watching this, as you're sitting and watching this video, Andromeda is approaching us. It's moving toward us at about 110 kilometers per second. That's about 250,000 miles per hour. Can you even comprehend that speed? 250,000 miles per hour. That's fast enough to circle the Earth in just a few minutes. That's faster than any spacecraft humans have ever built. And that's the speed at which an entire galaxy, with 1 trillion stars and unimaginable amounts of mass, is moving toward us. Moving toward our galaxy. Moving directly toward our home. For the past few million years, it's been getting closer. In millions of years more, it will get closer still. And then, in 4.5 billion years, it will arrive. But here's what's truly astonishing. We can actually see this galaxy approaching. We can actually watch it get closer. We can see its light. We can observe its motion. We can measure how fast it's approaching. And we know with mathematical certainty that it will arrive. Most people don't realize we can actually see Andromeda from Earth. On a clear, dark night, if you know where to look, you can see it with your naked eye. It's the most distant object humans can see without a telescope. It's about 2.5 million light-years away. That means the light we're seeing from Andromeda right now left that galaxy 2.5 million years ago. We're literally looking at the past. We're seeing Andromeda not as it is today, but as it was when early human ancestors were walking across the African savanna. Early humans were evolving. They were learning to use tools. They were developing language. They were becoming more intelligent. And all that time, for those millions of years, Andromeda was moving, getting closer, relentlessly, inexorably, preparing for the collision. The light we see today shows us what Andromeda looked like 2.5 million years ago. But Andromeda in the present moment is closer, much closer. By the time that light reaches us, Andromeda has moved. It's advanced further on its inexorable journey toward us. When you think about Andromeda, you need to understand what it actually is. It's not just a point of light in the sky. It's not just a star. It's an entire galaxy. It contains roughly 1 trillion stars. Let's think about that number for a moment. 1 trillion. That's 1 million million thousand. That's a million million. That's more stars than there are grains of sand on all the beaches on Earth. And Andromeda contains all of them. Every single one of those stars is a sun. Some are larger than our sun, some are smaller, some have planets orbiting them, some don't. But each one is a massive fusion reactor. Each one is a thermonuclear bomb continuously exploding, converting hydrogen into helium, creating the energy that lights the galaxy. And Andromeda has 1 trillion of them. all moving through space together as a single unified structure, all orbiting the galactic center, all held together by gravity. But wait, this wasn't always known. For most of human history, we didn't even know Andromeda existed as a separate galaxy. We thought the Milky Way was the entire universe. Everything that existed was contained within our galaxy. There was nothing beyond it, nothing outside, just an infinite void. But then telescopes improved. Astronomers like Edwin Hubble looked deeper into space, and they discovered that the cloudy patch we called Andromeda was actually another entire galaxy. Thousands of billions of stars, millions of billions of planets, an entire universe unto itself, separate from our own. And it was moving toward us. The realization was shocking. It changed our understanding of the universe fundamentally. We were no longer in a universe consisting of a single galaxy. We were in a universe containing billions of galaxies. And we shared that universe with other massive structures, including Andromeda, which was moving toward us. The realization that Andromeda was approaching created a new field of scientific inquiry. Scientists began to ask, what if it collides with us? What would happen? Could we predict what would occur? Could we understand the consequences? And so they did what scientists do. They built computer models. They created mathematical simulations. They simulated the collision over and over again, examining every possible outcome. They used the most powerful supercomputers in the world to run these simulations. They modeled how gravity would affect the stars. They modeled how the galaxies would deform. They modeled how planets would scatter. They modeled how new stars would form. And what they discovered was astonishing. What they discovered was shocking. What they discovered would fundamentally change how we think about our galaxy, about our solar system, about our future. The collision wasn't just going to be violent, it was going to be almost incomprehensibly catastrophic, but in ways that nobody had anticipated. But here's what most people don't understand about this collision. It won't happen all at once. It won't be like two cars crashing, where impact is sudden and complete. No. The collision between Andromeda and the Milky Way will unfold over hundreds of millions of years. It will happen in stages. It will be a slow-motion catastrophe, a gradual apocalypse that stretches across timescales so vast that they're almost incomprehensible to human minds. We think in terms of years, maybe decades, maybe centuries if we're thinking about long historical periods. But this collision will unfold over hundreds of millions of years. It will unfold over time periods that are longer than the entire evolutionary history of all life on Earth. And the first signs are subtle. They're almost imperceptible, but they're real. They're happening. They're already being set in motion. About 2 billion years from now, which is roughly 2.5 billion years before the actual collision, Andromeda will be close enough that its gravity will start affecting our galaxy in noticeable ways. The gravitational reach of Andromeda is immense. Remember, Andromeda is roughly twice as massive as the Milky Way. It's a bigger galaxy, it's more powerful, and gravity reaches across space. It doesn't require contact, it doesn't require physical proximity. Gravity is a force that acts across vast distances. And Andromeda's gravitational reach will extend across the millions of light years that currently separate us from the approaching galaxy. When Andromeda is still millions of light years away, its gravity will be affecting our galaxy, affecting the stars in our galaxy, affecting their orbits, affecting their motion, affecting the very structure of the Milky Way. The first effect will be subtle. Distant stars in the outer reaches of the Milky Way will start to be disturbed. Stars that have been orbiting the galactic center for billions of years will suddenly find their orbits becoming less stable. The gravitational pull from Andromeda will be tugging at them, pulling them in slightly different directions. The orbits won't change dramatically at first, not noticeably, but measurably. Astronomers would notice. Scientists would see it happening through their telescopes. They would measure the changing positions of stars. They would track how their orbits are becoming more eccentric, more unstable, less predictable, and they would realize, this is the beginning. This is the moment the universe starts reshaping itself. This is the signal that the collision is truly coming. What happened next was even more shocking to astronomers when they first realized it. They realized that before Andromeda even physically collides with our galaxy, its gravitational influence will be tearing the Milky Way apart from millions of miles away. Gravity doesn't require contact. This is the key insight. Andromeda's gravity is immense, and that gravitational reach will start to distort everything about our galaxy's structure. The spiral arms of the Milky Way, those beautiful iconic shapes that make our galaxy distinctive, that astronomers have observed and studied for centuries, that define the structure we live in, will begin to warp. They'll start to bend. They'll be stretched out of their normal shape by Andromeda's approach. And this will happen long before the actual collision, long before the galaxies physically touch. This will happen over hundreds of millions of years. A slow, inexorable distortion, a gradual reshaping. The Milky Way's spiral arms are held in their current shape by a delicate balance of forces. The rotation of the galaxy creates centrifugal forces that tend to spread the stars outward. Gravity creates forces that pull the stars inward. These two forces balance each other out, creating the beautiful spiral structure we see. But when Andromeda approaches, it introduces a new force into the equation, a new gravitational pull, a new tidal effect. This new force will begin to deform the spiral arms. It will pull at them. It will distort them. It will stretch them out. The spiral structure will begin to warp. The arms will become less tightly wound. The geometry of the galaxy will begin to change. And this change will accelerate as Andromeda gets closer. And then, about 1 billion years before impact, the real violence begins. Not the collision itself, but the first gravitational interactions that signal what's coming. The gravitational tidal forces become stronger, much stronger. The outer stars of the Milky Way will be ripped away, literally torn from the galaxy by Andromeda's gravity. Stars that have orbited the Milky Way's center for billions of years will suddenly find themselves being pulled away, flung outward like debris from an explosion. Except it won't be an explosion. It will be gravity, pure gravity, the most powerful force in the universe. And it will be remorseless. It will be unstoppable. It will tear apart everything in its path. Stars will be ejected from the Milky Way. They will become rogue stars, no longer part of any galaxy, drifting through the void of intergalactic space. Billions of them, trillions of them, all being scattered, all being dispersed, all being lost to the void. But here's the strangest part, the really unsettling part. The solar system, our solar system, might actually survive this first stage. Our sun is located in the galactic disk of the Milky Way. It's positioned in one of the spiral arms. It's about 26,000 light-years from the galactic center. It's in the outer regions. And depending on exactly how Andromeda approaches, depending on the angle of collision, depending on the specific configuration of gravitational forces, our region of the galaxy might not be directly affected by the first waves of gravitational violence. We might watch as distant stars are torn away. We might watch as the galaxy is distorted. We might observe the violence from a distance, but we might survive the opening stages of the collision. For now, this is shocking discovery number 1. Our solar system might actually survive the initial approach phase of the galactic merger, but the reprieve would be temporary. The relative safety of the outer regions wouldn't last forever. As Andromeda got closer and closer, as the gravitational forces became stronger and stronger, even the outer regions would begin to feel the effects. The stability of our orbit would begin to deteriorate. The protective bubble of relative calm would begin to shrink. And eventually, inevitably, the violence would reach our region of space. The question wasn't whether the outer regions would be affected. The question was when. This is shocking discovery number 2. Even the outer regions will eventually feel the full force of the collision. Now we need to understand something truly astonishing about galaxies. Something that changes everything about how we think about galactic collisions. At the center of nearly every galaxy lies something that's almost incomprehensible. At the center of nearly every galaxy lies a supermassive black hole. Yes, you heard that right, a black hole. An object so dense, so massive, so powerful that not even light can escape from its gravity once you get too close. The Milky Way has one. Sagittarius A is the name of our supermassive black hole. It has a mass of about 4 million suns. That means if you took 4 million objects the size of our sun and combined them into a single point, you would have the mass of Sagittarius A. It's absolutely enormous. It's incomprehensibly massive, and it's at the center of our galaxy. And Andromeda has a supermassive black hole too, but Andromeda's black hole is even bigger. It has a mass of about 150 million suns. That's 37 times more massive than ours. Imagine 150 million suns. Imagine all of that mass compressed into a single point. Imagine the gravity. Imagine the power. It's almost impossible to comprehend. And when these two gravitational monsters get close to each other, when they get within a few million miles of each other, they will interact. They will affect each other, and the results will be catastrophic for everything around them. The two black holes will begin to orbit each other. This is called a binary black hole system, and it's one of the most violent phenomena in the universe. The black holes will spiral inward toward each other, and as they do, something remarkable will happen. They will release gravitational waves, literal ripples in the fabric of space-time itself. This is not a metaphor. This is not an analogy. This is physics. Space-time itself, the four-dimensional fabric that makes up the universe, will ripple, it will undulate, it will wave. And these waves will radiate outward in all directions, expanding at the speed of light, like ripples in a pond, but ripples in the very fabric of reality itself. This process is called gravitational wave emission, and it's one of the most energetic processes in the universe. The black holes lose energy as they emit these gravitational waves. As they lose energy, their orbits decay, they get closer to each other, their orbital period decreases. They orbit faster and faster. The gravitational waves become more intense. More power is radiated away. The orbits decay faster, and everything around them is affected. Stars near the galactic center will be pulled toward the black holes. Some will be torn apart by the tidal forces. The gravitational force on the near side of a star will be vastly stronger than the force on the far side. This difference will literally rip the star to pieces. Some stars will be swallowed entirely by the black holes. They'll spiral inward and cross the event horizon, the point of no return, and vanish from our universe. The region around the galactic center will become a maelstrom of violence, chaos, destruction. Everything will be in turmoil, and this process will happen over millions of years, not suddenly, not all at once, but gradually, inexorably. The two black holes will get closer and closer. The orbit will get faster and faster, and the destruction around them will intensify. Millions of years of violence, millions of years of chaos, millions of years of stars being torn apart and destroyed. This is shocking discovery number 3. When the black holes of two colliding galaxies approach each other, they emit gravitational waves and create a region of intense destruction around them. And then something even more extreme happens, what scientists call the merger event. When the two black holes finally get close enough, and this could take tens of millions of years, they will stop orbiting each other. They will stop being two separate objects. They will merge. They will become one. They will fuse into a single, larger black hole. And in that moment, in that instant when they merge, something extraordinary occurs. Something that should frighten anyone who understands what's happening. The gravitational waves they emit will be catastrophically powerful. Waves so strong that they will shake the entire galactic structure. They will propagate outward at the speed of light. They will reach every corner of the merged galaxy. They will reach regions billions of miles away from the galactic center, and everything in their path will be affected. Stars will shake. Planets will be jostled from their orbits. Asteroids will be scattered. The very fabric of space around these worlds will ripple and undulate. And the energy released in that moment will be staggering. Let me be clear about how staggering. Scientists estimate that a black hole merger of this magnitude would release more energy in the form of gravitational waves than all the stars in both galaxies combined produce as light in their entire lifetimes. Let that sink in. More energy than all the stars in both galaxies combined. Think about that. The Milky Way contains about 200 billion to 400 billion stars. Andromeda contains about 1 trillion stars. So combined, that's over 1 trillion stars. And the gravitational waves from the black hole merger would release more energy than all trillion of those stars combined produce as light in their entire lifetimes. The energy is staggering. The power is incomprehensible. This is shocking discovery number 4. The gravitational waves from the black hole merger release more energy than all the stars in both galaxies combined. But wait, this wasn't the strangest part. What scientists found next was even more disturbing. The gravitational waves from the black hole merger won't just affect the region around the galactic center. They'll propagate outward through the entire galaxy. They'll reach the outer regions where our solar system is located. And they will pass through it. They will shake it. They will alter the orbits of planets and stars. It won't destroy our solar system directly. The effect won't be catastrophic at that range. The energy will have spread out over a vast distance. The intensity will have decreased. But it will be noticeable, it will be real, and it will be a sign that something profound has changed. A sign that the galaxies are no longer two separate systems. They are merging. They are becoming one. They are transforming into a new structure. This is shocking discovery number 5. The gravitational waves from the black hole merger will reach our solar system billions of miles away and shake it. Now we need to understand what actually happens during a galactic collision. And this is where the situation becomes truly astonishing. Because galaxies are mostly empty space. When people hear that two galaxies are going to collide, they imagine something like two solid objects smashing together, two balls crashing, two cars colliding, catastrophic impact, complete annihilation, debris flying everywhere. But that's not what happens. That's not how galaxies work. That's a misunderstanding based on objects at human scales. Galaxies are vast, sparse structures. Enormously vast. The Milky Way is about 100,000 light-years across. A light-year is the distance light travels in 1 year, traveling at 186,000 miles per second. So 100,000 light-years is an incomprehensible distance. But that's about 3 million trillion miles across. But here's the thing, that's almost entirely empty space. The stars in our galaxy are so far apart that if you shrank the Milky Way down to the size of a city, the stars would be separated by miles. Most of the galaxy is nothing, just empty space. Empty void, almost nothing. Same with Andromeda, same with every galaxy. Galaxies might look solid in pictures, they might look dense, they might look packed with stars, but they're mostly empty. This is shocking discovery number 6. Galaxies are mostly empty space, even though they contain hundreds of billions to trillions of stars. So when two galaxies collide, something surprising happens. The stars almost never hit each other. Stars pass by stars without colliding. The probability of two stars actually touching during a galactic merger is infinitesimally small. So small that it's almost impossible to calculate. Over trillions and trillions of stellar encounters, maybe a handful would actually crash. But the vast, overwhelming majority of stars would pass by each other. They would come close. They would be affected by each other's gravity. They would have their orbits altered. But they wouldn't collide. They wouldn't physically touch. This is shocking discovery number 7. During a galactic collision, the vast majority of stars don't actually hit each other. What actually happens during a galactic collision is gravitational reorganization. Andromeda's gravity will pull at the Milky Way. The Milky Way's gravity will pull at Andromeda. The two galaxies will deform. They'll change shape. Their spiral arms will be stretched and distorted by the gravitational tidal forces. Some stars will be flung outward by these forces. Some will be pulled inward. Some will remain in roughly their current orbits, but with altered trajectories. The whole structure will be rearranged by gravity. Gravity will reorganize everything. This is where it gets truly fascinating. Scientists call this a galactic merger, and it's a process that's already happened in the universe many times. We can see evidence of it in other galaxies. We can observe galaxies that are currently merging with each other. We can watch the process in action, even though it unfolds over millions of years, which is why we can't see the motion happen in real time. But by observing multiple galaxies at different stages of merger, we can piece together what happens. We can see the distorted shapes galaxies make as they interact. We can see the dust and gas being stirred up. We can see the violence. And we know that what we're observing in those galaxies is a preview of what will happen to us. The collision will actually happen in stages, multiple passages. Andromeda won't just crash into the Milky Way once and then settle down. No, the two galaxies will pass through each other multiple times. They will orbit around each other as they merge. Each passage will cause more distortion. Each encounter will pull them closer together. Each close approach will increase the gravitational effects. And over hundreds of millions of years, they will gradually spiral inward toward each other until eventually they merge completely into a single galaxy, a new galaxy, a bigger galaxy, a combined structure that will be completely different from either of its parent galaxies. And this new galaxy will have a new name. Astronomers are already debating what to call it. Some suggest Milkomeda, others suggest Milkdromeda. But whatever we call it, it will be the result of the most catastrophic event in the history of the Milky Way. But here's what makes this even more astonishing. The collision, violent as it is, might actually trigger an explosion of star formation. When galaxies collide, they stir up all the gas and dust in the galaxies. This gas and dust, when compressed and heated, becomes the raw material for new stars. So in the midst of the collision, in the middle of the chaos and destruction, billions and billions of new stars will be born, trillions of them. Entire regions of space will be ablaze with the light of newly formed stars. The collision will be violent, it will be destructive. But it will also be creative. It will generate new stars. It will create new planetary systems. It will create the raw material for new life. But at the same time, it will destroy existing planets. It will wipe out existing civilizations. It will remake the universe in its image. This is shocking discovery number 8. Galactic mergers trigger both destruction of existing structures and creation of new ones. Now we get to the question that really matters. The question that brings this cosmic catastrophe down to a personal level. What happens to our solar system? What happens to Earth? What happens to life? What happens to us? The answer depends on many factors. The answer depends on where our solar system is when the collision begins. The answer depends on how Andromeda approaches. The answer depends on gravitational interactions we can't predict with perfect accuracy. But we can model probabilities. We can use simulations to understand the range of possible outcomes. And what those simulations reveal is both reassuring and terrifying. Our solar system is located in one of the spiral arms of the Milky Way. We're about 26,000 light-years from the galactic center. We're in the outer regions, we're not in the middle. This is actually fortunate. Stars near the galactic center will be affected more dramatically than stars in the outer regions. The gravitational violence will be most intense near the center. The orbits will be most severely disrupted near the center. The danger will be greatest near the center. But we won't be unaffected. Far from it. The outer regions will feel the effects of the collision too, maybe not as intensely as the central regions, but definitely significantly. When Andromeda approaches, its gravity will start to affect our solar system immediately. Not catastrophically at first, but noticeably. The Sun's gravity keeps the planets in their orbits. Earth orbits the Sun because the Sun's gravity is pulling on us. constantly pulling us toward the sun, and we're moving fast enough that we keep missing the sun, keep falling around it in an elliptical orbit. But if a massive external force, like Andromeda's gravity, starts pulling on us from a different direction, our orbit will change, our trajectory will alter. We might be pulled slightly inward toward the sun, or slightly outward, or into an entirely different orbit. The calculations are complex because it depends on exactly where Andromeda is when it approaches. It depends on the specific gravitational configuration. But the bottom line is clear: our orbit will change. Our current orbit around the sun is not guaranteed to remain stable. This is shocking discovery number 9. The gravitational effects from Andromeda will change Earth's orbit around the sun. Now, a small change in Earth's orbit might not seem catastrophic, but even tiny orbital changes can have enormous consequences. Physics is precise. The conditions for life on Earth are finely tuned. Life on Earth has evolved under very specific conditions. Very specific temperature ranges, very specific radiation levels, very specific distances from the sun. If Earth moves even slightly closer to the sun, the planet will warm, the oceans will heat up, ice caps will melt, the entire climate system will shift, ecosystems will collapse, life will struggle to survive. If Earth moves slightly farther away, the planet will cool, temperatures will drop, life will struggle to survive in a different way. If the change is large enough, Earth could be ejected from its orbit entirely. This is a crucial point. If the gravitational forces from Andromeda are strong enough, if the orbital dynamics work out a certain way, the sun's gravity might no longer be strong enough to keep Earth orbiting. We would be flung out into the void of space, leaving the solar system entirely. Earth would become a rogue planet. We wouldn't be orbiting the sun anymore. We'd be drifting, hurtling through space at tremendous velocity, no longer basking in stellar radiation, no longer in a safe, predictable orbit. Just a cold, dark, lonely world, moving through the void at thousands of miles per hour. This is shocking discovery number 10. Earth might not remain in orbit around the sun. But wait, the situation gets even more dire, because the sun itself might not survive what's coming. The sun is one star among hundreds of billions in the Milky Way. When Andromeda collides with the Milky Way, gravitational forces will be rearranging stars throughout both galaxies. Some stars will be flung inward toward the galactic center. Some will be pulled outward. Some will be completely ejected from the galaxy entirely. And the probability of our sun being ejected is actually quite high. Scientists estimate that roughly 50% of stars in the Milky Way could be ejected from the galaxy during the merger process. Ejected, thrown out, lost to the void, cast out into the intergalactic medium. If this happens to our sun, it won't be part of the merged galaxy. It won't be part of the new structure that forms. It will be alone, adrift in the space between galaxies, and Earth would go with it. Still orbiting, still bound by the sun's gravity, but orbiting a star that's no longer part of any galaxy. Orbiting in the darkness, in the emptiness, in the void. This is shocking discovery number 11. There's roughly a 50% chance our sun will be completely ejected from the Milky Way. And then there's another possibility. A possibility that might actually be worse. What if our sun doesn't get ejected, but instead gets pulled inward? What if the collision's gravitational forces drag the sun toward the galactic center? If this happens, the sun would start to orbit the galactic center on a very different trajectory than it does now. It might get pulled much closer to the center. It might end up in a region of the galaxy that's far more violent, far more chaotic, far more dangerous than our current location. It might end up near other stars, and near other stars means the danger of stellar collisions increases dramatically. Two stars colliding is extraordinarily rare in isolation. But if our sun gets pulled into a dense region of space with billions of other stars, the odds increase exponentially. Our sun might collide with another star. It might be torn apart by stellar interactions. It might be completely destroyed. This is shocking discovery number 12. Our sun could be dragged toward the galactic center and destroyed in collisions with other stars. But let's imagine a slightly more optimistic scenario. Let's imagine our sun survives the collision. Let's imagine it remains in orbit around the galactic center, just in a slightly different orbit than it does now. Even in this scenario, everything changes, because the collision will stir up all the gas and dust in both galaxies. This material will be compressed, heated, energized. New stars will form in tremendous numbers, billions and billions of them, trillions of them. The collision will trigger star formation on an unprecedented scale, and new stars mean radiation, lots of it. The collision will fill the entire galaxy with stellar radiation, light, heat, and energy from billions of young stars, many of them much more massive and luminous than our sun. Our solar system will be bathed in this radiation. The background radiation environment of the galaxy will completely change. This could have dramatic effects on Earth. Increased radiation could damage the ozone layer. It could increase mutation rates in organisms. It could trigger extinction events. It could fundamentally alter the conditions for life on Earth. This is shocking discovery number 13. Even if our solar system survives intact, the increased radiation from the collision could make Earth uninhabitable. There's another factor too. If Andromeda passes close to our Sun but doesn't eject it, it could significantly affect the orbits of the planets in our solar system. Not just Earth, but all of them. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. All of their orbits could be altered. Some might be pulled slightly inward toward the Sun. Others might be pushed outward. The entire architecture of the solar system could change. The habitable zone, the region around the Sun where planets can have liquid water and potentially support life, would shift. If Earth gets pushed farther from the Sun, it would move out of the habitable zone. If Mercury gets pulled inward too far, it might collide with the Sun. If one of the outer planets gets pulled too far inward, it might destabilize the entire solar system. This is shocking discovery number 14. The entire architecture of the solar system could change due to Andromeda's gravitational influence. Now let's explore what might be the most terrifying scenario, the one that scientists discovered when they ran their most sophisticated simulations, the one that appeared again and again in the computer models. When you run the numbers, when you simulate the gravitational interactions, when you model what happens to individual planets during a galactic merger, you discover something shocking, something that defies our intuition about planetary systems. Most planets don't stay where they are. Most planets don't remain in orbit around their parent stars. Most planets get ejected. They're flung outward by gravitational interactions. They're pulled away by the gravitational influence of nearby stars. They're scattered, dispersed, lost to the void. This is shocking discovery number 15. Roughly 90% of planets could be ejected from their orbits during a galactic merger, 90%. That's not a small percentage. That's not a minority. That's the vast majority. When you run the numbers, when you simulate the gravitational interactions, when you model what happens to individual planets during a galactic collision, you discover that most planets don't survive. They don't stay in their orbits. They get ejected, scattered, sent into the void. This means Earth probably won't stay in orbit around the Sun. This means that during the collision, we'll most likely be ejected. And if that happens, everything changes. Everything about our world changes. Everything about the future changes. What scientists call a rogue planet is a planet that's no longer orbiting a star. It's a planet that's traveling through space on its own, alone, unsupported by stellar radiation, unsupported by the energy that makes life possible. Earth would become rogue, and here's what that means. Earth would get very, very cold. The Sun provides all the energy that makes life on Earth possible. The Sun's radiation warms the planet. Without it, the planet cools. The Sun's radiation drives photosynthesis, which produces food for plants and animals. Without it, plants can't make food. The food chain collapses. The Sun's radiation creates weather patterns. Without it, atmospheric circulation would change. The Sun's gravity keeps Earth in orbit. Without it, we'd drift away. Every aspect of life on Earth depends on the Sun, every single aspect. Remove the Sun, and everything falls apart. When Earth becomes a rogue planet, when it gets ejected from the solar system, it would drift away into the void, and as it did, it would cool down. The temperature would drop dramatically. Within a few years, the surface would freeze. Within a few decades, the atmosphere would liquefy and fall as rain, then freeze solid. The oceans would become solid ice. Every drop of water would freeze. The entire planet would be locked in permanent winter. This is shocking discovery number 16. Earth would become a frozen, lifeless world if it were ejected from the solar system. And then the darkness comes. Without the Sun, Earth would be plunged into complete darkness. No sunlight. No starlight nearby, just the darkness of space. The temperature would drop to nearly absolute zero, nearly as cold as it gets anywhere in the universe. Life as we know it would be impossible. All organisms would die. Plants would die first, unable to photosynthesize without sunlight. Animals would follow, starving and freezing. Bacteria would die. Viruses would inactivate. Fungi would cease to reproduce. Everything alive on Earth would cease to exist. The planet would become a tomb, a frozen, dark, lifeless tomb hurtling through the void. This is the most nightmarish scenario, but it's not the worst-case scenario. There's an even worse possibility. What if Earth doesn't just become a rogue planet orbiting nothing? What if it gets captured by another star? What if, as it's being ejected from the solar system, it passes close enough to another star for that star's gravity to capture it? This could happen. In a galactic collision, there are billions of stars being thrown around. There are billions of encounters happening. The chances of Earth getting captured by another star are actually not trivial. They're significant. And if this happens, Earth would be in an entirely new planetary system, orbiting an alien star. And that star might be nothing like our Sun. It might be a red dwarf, a small, cool star. It might be a blue giant, a massive hot star. It might be a white dwarf, a dead star. The remnant of a star that once was but has burned out, it might be a neutron star. An even more exotic object. Earth would be orbiting a star it's completely unprepared for. Life on Earth has evolved in specific response to the sun's colour, the sun's brightness, the sun's energy output, the sun's stability. If Earth ends up orbiting a completely different star, the conditions would be unrecognizable. Life might not survive. This is shocking discovery number 17. Earth could be captured by another star and end up orbiting an alien sun. But here's what's even more astonishing. Scientists discovered that if Earth gets captured by another star, it might get captured by a binary star system, a system with two stars orbiting each other. And if Earth ends up in a binary system, the gravitational situation becomes incredibly complex. Earth might orbit one star, it might orbit both stars, it might be in a stable orbit. It might be in a chaotic, unpredictable orbit. The situation would be completely different from what life on Earth has ever experienced. The temperature might vary wildly. The radiation might be intense and unpredictable. Different wavelengths of light might dominate depending on which star is currently closer. Life would struggle. Adaptation would be almost impossible. Civilization, if humans still existed, would be almost impossible to maintain. This is shocking discovery number 18. Earth could end up in a binary star system where orbital dynamics are chaotic and unpredictable. There's another scenario too. What if Earth doesn't get captured by just any star, but specifically by a red dwarf? Red dwarfs are the most common type of star in the galaxy. They're small, they're cool, they're faint. If Earth got captured by a red dwarf and ended up in the habitable zone of that star, the region where liquid water could potentially exist, Earth might remain habitable. The conditions would be different from what Earth experiences now. The light would be red instead of white. The radiation environment would be different. But life might be able to adapt. This is shocking discovery number 19. If Earth gets captured by a red dwarf, it might remain habitable. But there are also scenarios where Earth gets captured by a star that's dying. A white dwarf, a neutron star, a star that's reaching the end of its life. In these scenarios, Earth would be orbiting a star with very different properties from our Sun. A white dwarf, for example, is incredibly hot and incredibly dense. A piece of white dwarf material the size of Earth would weigh as much as the Sun. The gravity would be intense. If Earth got too close to a white dwarf, it would be torn apart by tidal forces. This is shocking discovery number 20. Earth could be destroyed if it gets captured by certain types of stars. Now let's talk about timing in greater detail. When exactly will this happen? How long do we have? What are the specific stages? The answer is both reassuring and terrifying. We have about 4.5 billion years. That's roughly the time remaining before the actual collision occurs. 4.5 billion years is an incomprehensibly long time. It's so long that it seems almost irrelevant. It's longer than all of recorded history. It's longer than the entire existence of human civilization. It's longer than the entire evolutionary history of Homo sapiens. It's longer than most people can even conceptualize. But here's the thing. All the catastrophic events we've been discussing don't happen at the collision itself. They start before. Millions of years before. The gravitational effects begin when Andromeda is still millions of light years away. The distortion of our galaxy begins when the collision is still invisible to any human observers. The danger is already starting. In a sense, the collision is already underway. It's just moving very slowly. Let's establish a detailed timeline. This is where it gets really fascinating because scientists have actually modeled this precisely. They've used supercomputers to simulate the collision. They've run the numbers over and over. They've established detailed timelines of events. About 2 billion years from now, Andromeda will be close enough that its gravity will start to noticeably affect the Milky Way. At this time, Andromeda will be about 9 million light-years away, still incredibly distant. Still far enough that it would take light 9 million years to travel from Andromeda to us. But it will be close enough that its gravitational effects will be noticeable. Distant stars in the outer reaches of our galaxy will start to be disturbed. Their orbits will begin to change. This is subtle at first, barely noticeable, but it's real. And it's the first sign that the collision is truly happening. About 1 billion years from now, Andromeda will be about 5 million light-years away. The effects become more severe. Andromeda will be close enough that significant numbers of stars will be ejected from the Milky Way. Our galaxy will start to take on a distorted shape. The spiral arms will start to warp. The beautiful spiral structure will start to become unrecognizable. But the actual collision, the first physical encounter where the stars and dust of both galaxies start to mix, hasn't happened yet. The galaxies are approaching, but they're not yet touching. The gravitational effects are being felt, but the actual merger hasn't begun. About 750 million years from now, Andromeda will be about 3 million light-years away. The situation will be even more dramatic. From Earth, if humans are still around to observe it, Andromeda will be noticeably larger in the sky. It will be growing visibly larger with each passing generation. Astronomers would be able to measure its expansion. They would be able to calculate the approach rate. They would know with certainty that a collision is imminent. But they would still have hundreds of millions of years to prepare. Time would still exist. The catastrophe would still be distant. About 500 million years from now, Andromeda will be about 1 million light-years away. This is when the first real collision occurs. This is the moment when Andromeda's stars first start to mingle with the Milky Way's stars. This is when the two galaxies actually start to merge. This is when things get violent. This is when the ejection of stars really increases. Our solar system, if it's not ejected, will be jostled. Our orbit will change. The background radiation environment will start to shift. But we're still far from the final merger. The galaxies are in the opening stages of their encounter. Multiple passes will still occur. This is shocking discovery number 21. The actual merger begins about 500 million years before the final collision. After this first collision, the two galaxies will separate slightly. They'll go through multiple passes. Each pass will pull them closer together. Each pass will cause more distortion. Each pass will increase the rate of star ejection. Every encounter brings more violence. Every encounter brings more destruction. Billions of years from now, the merger will be obviously under the way. The night sky, if there are creatures to look at it, will be dramatically different. Andromeda will dominate the sky. It will be growing. It will be obvious that a collision is happening. About 300 million years from now, a second major collision occurs. The galaxies are now extremely close. They're visibly merging. From Earth, if observers exist, Andromeda would fill a significant portion of the night sky. The gravitational effects would be undeniable. The violence would be obvious. Stars would be visibly falling out of the sky. Planets would be scattered. This is the period of most intense violence. This is when the most stars are being ejected. This is when the most planets are being scattered. This is when the situation is most chaotic. About 200 million years from now, multiple more collisions occur. The galaxies are spiraling inward toward each other. They're getting closer with each pass. The merger is becoming obviously complete. The structure of both galaxies is being completely reorganized. The spiral arms are being torn apart. The disk is being disrupted. The central regions are heating up. Stars are being born and dying on an unprecedented scale. This is shocking discovery number 22. The merger will occur in multiple passages over a period of several hundred million years. About 100 million years from now, a time when Earth might be populated by life forms so different from us that they're almost unrecognizable, the merger becomes nearly complete. The two galaxies are no longer distinct objects. They're merging together. The supermassive black holes are almost close enough to merge. The gravitational violence is at its peak. This is the most dangerous period. This is when the most stars are being ejected. This is when the most planets are being scattered. This is when the situation is most chaotic. This is when stability is least assured. This is shocking discovery number 23. The most violent phase of the merger occurs about 100 million years before the final collision. About 50 million years from now, the supermassive black holes finally merge. The gravitational waves from the merger propagate outward. The entire merged galaxy shakes. And then, gradually, the violence decreases. The two galaxies have settled down, they've become one. The new galaxy, Milkomeda or Milkdromeda or whatever we want to call it, begins to stabilize. It's a bigger galaxy than either parent galaxy. It has different structure, different shape, different properties, but it's stable. The collision is over. Life, if it has survived, can begin to adapt to a new galactic environment. This is shocking discovery number 24. The entire collision and merger process takes about 4.5 billion years. And here's what makes this timeline absolutely astonishing. The entire process takes about 4.5 billion years. That's incredibly long by human standards. By cosmic standards, it's remarkably quick. The collision will unfold over billions of years, with the most violent phases lasting hundreds of millions of years. This is not a quick catastrophe. It's not a sudden disaster. It's a slow, grinding, relentless transformation of the universe. And what's most shocking is that we can see it happening elsewhere. We can look at the Andromeda Galaxy right now with our telescopes, and we can see that it's deformed. It has tidal streams, long trails of stars that have been pulled away from the main body by interactions with other galaxies. Andromeda itself has suffered collisions with smaller galaxies in its past. It's not pristine, it's not perfect, it's been damaged, distorted, affected by interactions with other galaxies. And what we're seeing is a preview of what will happen to our galaxy when Andromeda arrives. This is shocking discovery number 25. We can already observe the effects of galactic collisions happening to Andromeda right now. Now let's talk about something that might be more optimistic. Is there any scenario in which life on Earth survives the collision? Is there any scenario in which civilization survives? Is there any scenario in which humans, or whatever descendants of humans might exist billions of years in the future, make it through this cosmic catastrophe? The answer is surprisingly complex. It depends on many factors. It depends on where our solar system is during the collision. It depends on whether Earth stays in orbit. It depends on the specific gravitational interactions. But yes, there are scenarios in which Earth survives, not unscathed, not unchanged, but surviving. The most optimistic scenario is one in which our solar system remains relatively undisturbed during the collision. This could happen if we're located far enough from the main collision zone. If Andromeda approaches from a certain angle and collides with the Milky Way in a certain way, the outer regions of the galaxy, where we're located, might be less affected than the central regions. In this scenario, our orbit around the Sun might change slightly, but we might remain in the habitable zone. The temperature on Earth might increase slightly or decrease slightly, but it might remain within ranges where life can survive. Life on Earth might survive, civilization might persist. And when the collision is over, we'd find ourselves in a new galaxy, orbiting a sun that still exists. It's in a solar system that still has planets. This is the best case scenario. But it's not guaranteed. It depends on a lot of factors. This is shocking discovery number 26. There is a scenario in which Earth survives the collision intact. A slightly less optimistic scenario is one in which Earth gets knocked out of the habitable zone but not completely ejected from the solar system. In this case, Earth might orbit the Sun at a distance where it's too cold for current life to survive. The planet would become frozen. The oceans would freeze solid. The atmosphere would freeze. But life on Earth is incredibly resilient. It has survived multiple extinction events. It has survived the Permian extinction 252 million years ago, when 96% of all marine species and 70% of terrestrial vertebrate species went extinct. It has survived the KPG extinction 66 million years ago, when an asteroid impact wiped out the dinosaurs. It has survived ice ages. It has survived asteroid impacts. It has survived supervolcanic eruptions. Life is tough. Life is adaptable. Extremophiles, organisms that thrive in extreme conditions, might be able to survive on a frozen Earth. Organisms that don't depend on photosynthesis might survive underground. Organisms that get their energy from geothermal sources might persist. Deep in Earth's crust, in geothermal hot springs, in subsurface aquifers, life might continue. And if Earth eventually drifts back into the habitable zone, which could happen if our orbit gradually changes back to its current position due to other gravitational interactions, life could flourish again. The planet could become warm again, the oceans could thaw, the atmosphere could return to habitable conditions, and life would emerge from its underground refuges and reclaim the surface. This is shocking discovery number 27. Even if Earth becomes temporarily uninhabitable, life might not be completely wiped out. And then there's the possibility that Earth doesn't survive as a planet orbiting the Sun, but that life does survive elsewhere. This is a fascinating scenario that scientists have explored. If Earth is ejected from the solar system and becomes a rogue planet, it would become a frozen, dark world. All surface life would die, the oceans would freeze, the atmosphere would freeze. But wait, Earth wouldn't be completely dead. Beneath the surface, in the deep subsurface, there might be life, microbial life, extremophiles, organisms that don't depend on solar energy. There are organisms on Earth today that live in deep caves, in deep ocean vents, in geothermal hot springs, completely isolated from the sun's energy. They get their energy from the planet itself, from geothermal heat, from radioactive decay in the planet's core. These organisms might survive on a frozen Earth. They might continue to live beneath the ice. They might adapt to conditions we can barely imagine. And remarkably, if Earth eventually got captured by another star, if it ended up in orbit around an alien sun, the surface might thaw again. Life might return to the surface. Earth might become habitable again, orbiting an alien star, in a completely different part of the galaxy. This is shocking discovery number 28. Life might survive on a rogue Earth and then resurface if Earth gets captured by another star. There's another possibility too. What if Earth doesn't survive but that human civilization does? What if humans develop advanced technology before the collision happens? What if humans leave Earth? What if humans build massive space habitats that can protect them from the collision? What if humans spread throughout the galaxy? What if human civilization becomes so distributed, so spread out, so protected that the collision can't destroy all of humanity? This is shocking discovery number 29. Human civilization might survive the collision through advanced technology and spreading throughout the galaxy. But here's the ultimate question that brings us back to perspective. Would human civilization even exist by the time the collision happens? Would humans be here to witness what happens? This is where the timeline becomes critical. Humans have existed for about 300,000 years. Civilization has existed for about 10,000 years. Modern, technological civilization has existed for maybe 200 years. We're an incredibly young species. We're an incredibly young civilization. And the collision is happening in 4.5 billion years. That's 15,000 times the current age of the human species. That's an unimaginably long time. In that time, human civilization might change beyond recognition. Humans might evolve into something entirely different. Humans might develop advanced technology that allows us to survive the collision. Humans might leave Earth entirely. We might colonize other planets. We might scatter throughout the galaxy. We might build space habitats that protect us from the collision. We might develop propulsion systems that let us move away from danger. Or humans might go extinct long before the collision happens. We might destroy ourselves. We might be wiped out by disease. We might be eliminated by climate change or asteroid impact. We might simply cease to exist. We have no way of knowing. This is shocking discovery number 30. We have no way of knowing whether humans will even exist when the collision happens. Now let's understand the physics in deeper detail. What exactly is happening when two galaxies collide? How does gravity work on this scale? The Milky Way has a mass of about 1.5 trillion suns. That's 1/5 by 1012 solar masses. That's an incredibly large number. To put it in perspective, if you were to count to 1.5 trillion, one number per second, it would take you about 47,500 years. Andromeda has a mass of about 2.5 trillion suns, even larger. These are almost incomprehensible numbers. You could write both numbers as thousands of billions, and both galaxies have this incredible mass. When two objects with this much mass get close to each other, the gravitational forces between them are staggering. Andromeda's gravity will reach across space and pull on every star in the Milky Way. The Milky Way's gravity will pull on every star in Andromeda, and neither galaxy can escape the other's gravity. They're locked together, they're bound to merge, they're destined to collide. This is shocking discovery number 31. The gravitational binding between the two galaxies is inescapable. Now, gravity is interesting because it doesn't just affect the centers of the galaxies. It affects every star, every planet, every particle. As Andromeda approaches, its gravity pulls harder on the near side of the Milky Way than on the far side. This difference is called a tidal force. It's the same phenomenon that causes tides in Earth's oceans. The Moon's gravity pulls harder on the near side of Earth than on the far side, creating a bulge in the oceans. Similarly, Andromeda's gravity will create tidal forces in the Milky Way. These forces will distort the galaxy. They'll stretch it, they'll warp it, they'll rip stars away from the galactic disk. And these effects get stronger as Andromeda gets closer. The tidal forces increase with the inverse cube of the distance. So if Andromeda gets twice as close, the tidal forces become 8 times stronger. If it gets 4 times closer, the forces become 64 times stronger. This means the violence accelerates as the collision approaches. One of the most fascinating aspects of a galactic collision is what happens to the dark matter. Now, you haven't heard much about dark matter yet in this script, so let me explain this carefully. Dark matter is an invisible substance that makes up most of the mass of galaxies. About 85% of the matter in the universe is dark matter. We can't see it, we can't detect it directly, we can't touch it. We can't interact with it through any of the forces we normally interact with matter through. But we know it's there because of its gravitational effects. And dark matter plays a crucial role in galactic structure. Dark matter forms a massive halo around every galaxy. This halo extends far beyond the visible stars and gas. The dark matter halo is what keeps the galaxy bound together. It's what keeps the stars from flying apart due to their orbital motion. The dark matter provides additional gravity that holds everything together. When two galaxies collide, their dark matter halos collide too. And this is where things get really interesting, because dark matter doesn't interact with ordinary matter the way stars and gas do. When two clouds of gas collide, they compress, they slow down, they heat up, they can stick together and merge. But when two dark matter halos collide, they pass through each other. The dark matter doesn't stick, it doesn't compress, it doesn't interact with the ordinary matter in ways that would slow it down. It just passes through, mostly undisturbed. This is shocking discovery number 32. Dark matter halos pass through each other during galactic collisions without significantly interacting. But the collision still has effects. The dark matter halos will merge together, creating a larger, more massive dark matter halo around the merged galaxy. This new dark matter halo will have different properties, different distribution, different gravitational effects. The dark matter won't be concentrated in the same way it was in the parent galaxies. The gravitational environment will change, and this change affects ordinary matter. It affects stars. It affects planets. It affects the overall structure of the merged galaxy. This is shocking discovery number 33. Dark matter halos merge during galactic collisions, creating a new gravitational environment. Now let's talk about what happens to the gas and dust. Unlike dark matter, gas and dust do interact when galaxies collide. When clouds of gas from the Milky Way collide with clouds of gas from Andromeda, something remarkable happens. The clouds compress. They collide. They slow down relative to each other. The kinetic energy of their motion is converted into heat. The temperature in the collision zones skyrockets. We're talking about temperatures of millions of degrees. And here's where it gets fascinating. This extreme heating and compression is exactly what's needed to trigger star formation. The cold gas clouds are heated to temperatures where nuclear fusion can ignite. New stars begin to form, billions of them, potentially trillions of them. The collision between the two galaxies will trigger the largest burst of star formation in the history of both galaxies. This is shocking discovery number 34. Galactic collisions trigger unprecedented bursts of star formation. The new stars will be predominantly young, massive stars. These are bright stars that shine brilliantly. They're hot. They're blue-white in color, and many of them will have relatively short lifespans. Massive stars don't live as long as smaller stars, but while they live, they shine brightly. The entire merged galaxy will be illuminated. Blazing with the light of billions of newly formed stars, the merged galaxy will be young, it will be vibrant, it will be alive. It will be more luminous than either parent galaxy. From a distance, the merger would appear as a brilliant starburst, a region of intense star formation, a region literally ablaze with stellar light. This is shocking discovery number 35. The merged galaxy will be more luminous and more vibrant than either parent galaxy due to the burst of star formation. Imagine you're a being living 4.5 billion years in the future. Imagine you're observing what's happening in the night sky. What do you see? How does the catastrophe unfold from a visual perspective? For the first billion years, Andromeda remains a small fuzzy patch in the sky. It's visible to the naked eye, but it's distant. It's not obviously threatening, it's just there. A nebulous object. A cloudy patch. If you didn't know better, you might not even realize what it was. You might think it was just another nebula, just another feature of the night sky. But to an informed observer, to an astronomer, it's ominous, it's a warning, it's a harbinger of things to come. Gradually, over millions of years, it gets bigger, it gets closer. The fuzzy patch becomes a distinct feature. You might start to notice that it's closer than it used to be, but the change is so gradual, so slow, that you might not be consciously aware of it. It's only by comparing observations from generation to generation, from century to century, from millennium to millennium, that it becomes obvious. Andromeda is approaching. About 2 billion years before the collision, Andromeda is noticeably closer. It's much bigger in the night sky. It's obviously a distinct object now. It's obviously separate from the background stars. You can see structure in it. You can see the disk. You can see some of the spiral arms. It's obviously moving toward us. At this point, any civilization observing the sky would be acutely aware that a collision is coming. They would be able to calculate the timeline. They would know when it would happen. They would have millions of years to prepare. They would have time to think about what's coming. Time to plan. Time to wonder. Time to fear. About 1 billion years before the collision, Andromeda is dramatically bigger. It dominates the night sky. It's not just a patch anymore. It's a vast structure. You can see detail in it. You can see the spiral arms clearly. You can see dust lanes, dark regions where dust obscures the light from stars behind it. You can see H2 regions, regions of glowing gas, where new stars are forming. You can see the entire structure. And it's obviously getting closer. So it's obviously on a collision course. And for any observer, for any civilization, for any conscious being looking at the sky, it's both beautiful and terrifying. Beautiful because it's a spectacular cosmic structure. Terrifying because you know it's on a collision course with your galaxy. You know that in a billion years it will collide. You know that when it does, everything will change. About 500 million years before the collision, Andromeda fills a quarter of the night sky. It's enormous. Its gravity is now obviously affecting the Milky Way. You can see the effects. The stars in the outer regions of the Milky Way are being drawn toward Andromeda. The galactic disk is starting to warp. The beautiful spiral structure is starting to distort. And in the sky, Andromeda itself is visibly being distorted. Its spiral arms are being stretched. It's being warped by its approach. The two galaxies are beginning to interact gravitationally. They're beginning to merge. And if you're an observer from the Milky Way, you're watching your own galaxy being torn apart. You're watching your home being transformed. It's a profound and disturbing experience. About 100 million years before the collision, the situation is obviously catastrophic. Andromeda fills half the sky. It's so close that its details are visible to the naked eye. Its stars are bright, its dust lanes are dark, its structure is obvious, and the gravitational effects are undeniable. The Milky Way is being torn apart. Stars are being ejected. The galactic structure is barely recognizable. It's almost impossible to call it the Milky Way anymore. It's been transformed, distorted. warped. It's a twisted, distorted version of its former self. And Andromeda itself is being distorted. The two galaxies are only a few million miles apart now. Only a few million miles. The collision is imminent. And any observer would be terrified. The collision is obvious. It's unavoidable. It's about to happen. And then it happens. The first collision. Andromeda crashes into the Milky Way. For the first time, the stars of the two galaxies start to mingle. The collision is violent. The shock waves are fierce. Temperatures in the collision zone spike. Temperatures millions of degrees. Gas clouds collide. They compress. They heat up. Stars are ripped away from their orbits. Planets are scattered. The entire region is ablaze with the light of billions of new stars forming in the collision zones. From a distance, the collision is spectacular. It's a breathtaking display of cosmic violence and creation. From a distance, you'd see two galaxies crashing together. You'd see a flash of light. You'd see a region of intense activity. You'd see the two structures merging, and you'd witness the birth of billions of stars, billions of new suns igniting, billions of new light sources coming to life. From a distance, it's an astonishing sight. This is shocking discovery number 36. The galactic collision is visually spectacular from a distance. But if you're close to it, if you're in the collision zone, it's pure violence. It's chaos. It's destruction. Stars are being torn apart. Planets are being flung into the void. Entire planetary systems are being destroyed. Entire civilizations, if they exist, are being wiped out. The violence is real. The destruction is real. The catastrophe is real. This is shocking discovery number 37. The galactic collision is pure violence and destruction up close. And it lasts for millions of years. Not just a moment. Not just a collision that happens and then is over. But millions and millions of years of violent creative activity. The collision unfolds in slow motion from a cosmic perspective, but it's still extraordinarily violent. For millions of years, the two galaxies are colliding. Stars are being created and destroyed. Planets are being scattered. The entire region is in turmoil. Eventually, the collision subsides. Andromeda and the Milky Way separate slightly, but they don't fully separate. They're not fully separated. Their gravity keeps them connected. They're locked together. They're bound by gravity. They're destined to merge. They orbit around their common center of mass. And gradually, they spiral back toward each other. They collide again and again. Each collision brings them closer. Each collision is somewhat less violent than the last, because the potential energy is being dissipated. The orbital energy is being lost through the generation of heat and the formation of stars. Eventually, after millions of years and multiple collisions, the two galaxies fully merge. They become one. The merger is complete, and a new galaxy emerges. This is shocking discovery number 38. The merger occurs through multiple collisions over millions of years. A bigger galaxy. A galaxy formed from the combination of two parents. And this new galaxy settles into a new configuration. It has a new structure, new spiral arms, new star-forming regions, new properties. And life, if it has survived, will have to adapt to this new galactic environment. The galaxy that emerges from the merger will be different from either parent galaxy. It will be transformed. And those who live in it, those who call it home, will find themselves living in a completely different galaxy. This is shocking discovery number 39. The merged galaxy is fundamentally different from either parent galaxy. We mentioned the supermassive black holes earlier, but let's explore their role in much greater detail. Because the black holes are crucial to understanding what happens during the merger. They're the engines of transformation. The Milky Way's supermassive black hole, Sagittarius A, has a mass of about 4 million suns. But what does this actually mean? What does it mean for an object to have the mass of 4 million suns? It means that if you could gather up 4 million stars the size of our sun and compress them all into a single point, you'd have Sagittarius A, all that mass compressed into a point. Not a planet, not a star, not even a neutron star, but a point, a singularity, an object where the normal laws of physics break down, where time itself becomes infinitely curved, where light itself cannot escape. Sagittarius A is so massive that it bends space-time around it. It curves space, it curves time. Objects near the black hole experience time differently than objects far from it. This is predicted by Einstein's general theory of relativity. Objects near the black hole experience time more slowly than objects far away. An observer falling into the black hole would experience time passing differently. But Sagittarius A, while massive, is actually relatively inactive. It's not in a state of high activity right now. It's not consuming large amounts of material. It's not shining brightly. It's relatively quiet. But Andromeda's black hole is different. Andromeda's supermassive black hole is larger, much larger. It has a mass of about 150 million suns. That's 37 times the mass of Sagittarius A. Imagine 150 million suns, all compressed into a single point, all that mass, all that gravity. It's incomprehensible. And when these two black holes get close to each other, when they get within a few million miles of each other, they will interact in ways that are truly profound. The smaller black hole from the Milky Way won't be able to resist the gravitational pull of Andromeda's larger black hole. It will be pulled toward it. It will start to orbit it. But this orbit won't be stable. The orbit will decay. The black hole from the Milky Way will spiral inward toward Andromeda's black hole. This is shocking discovery number 40. The smaller black hole will spiral inward toward the larger black hole. As the black holes spiral inward, as they orbit each other in tighter and tighter orbits, they will emit gravitational waves. These aren't small waves. These aren't subtle ripples. These are the most powerful waves that will ever be emitted from these black holes. The gravitational waves will carry away energy. And as energy is carried away, the black holes lose orbital energy. They spiral inward even faster. The orbits become tighter. The frequency of the orbits increases. The gravitational waves become more intense. And then, eventually, after millions of years of spiraling inward, the black holes will finally merge. They'll collide. They'll fuse into a single object. And in that instant, in that moment when the two event horizons meet and merge, something extraordinary happens. The gravitational waves reach their maximum intensity. The entire space-time of the merged galaxy vibrates. The very fabric of the universe ripples. And the energy released is staggering. Scientists estimate that a black hole merger of this magnitude would release more energy than all the stars in both galaxies combined produce as light in their entire lifetimes. Think about that for a moment. All the stars, all the light, the entire luminous output of 1 trillion stars, all released in a single moment, all radiating away as gravitational waves. This is shocking discovery number 41. The black hole merger releases more energy than all the stars in both galaxies combined. The gravitational waves from this merger will propagate outward at the speed of light. They'll reach every corner of the merged galaxy. They'll pass through all the star systems. They'll pass through our solar system. And they will shake everything they pass through. This is not metaphorical. This is literal. The space-time around Earth will ripple. The distance between objects will change slightly. The geometry of space will undulate. It won't be enough to destroy the solar system, but it will be enough to change orbits. It will be enough to jolt planets. It will be enough to demonstrate that something profound has changed. And here's something else that's remarkable about black hole mergers. They can produce a recoil. This is a prediction from general relativity that was confirmed through simulations. When two black holes merge, the merger isn't symmetric. The gravitational waves aren't emitted equally in all directions. Because of the orbital geometry, because of the way the two black holes are oriented relative to each other, the gravitational waves are stronger in some directions than others. This means more momentum is carried away in some directions, and this creates a recoil effect. The merged black hole can be kicked in one direction or another. The merged black hole can receive a velocity. It can start moving through space. This is shocking discovery number 42. The merged black hole can be kicked and start moving through the galaxy. This recoil effect has implications. If the merged black hole is kicked strongly enough, it could be displaced from the galactic center. It could move away from where the galactic center used to be. It could wander through the galaxy. It could end up in a different location entirely. This would dramatically change the structure of the merged galaxy. The galactic center would be displaced. The orbits of all the stars would change. Everything would be reorganized around the new location of the supermassive black hole. This is shocking discovery number 43. The merged black hole might be kicked away from the galactic center, displacing the gravitational center of the entire merged galaxy. And there's another consideration. The merged black hole will be larger. It will have the combined mass of both parent black holes. It will have more gravity. It will have a larger event horizon. It will have more influence on the surrounding galactic structure. The region around the merged black hole will be different from the regions around either of the parent black holes. The dynamics will be different. The orbits will be different. Everything will be reorganized around this new, larger central engine. Now let's zoom out and think about what this merger means for the broader cosmos. The Milky Way and Andromeda are not alone in the universe. There are other galaxies nearby. There's the Triangulum Galaxy, which is about 3 million light-years away. There are the Magellanic Clouds, which are satellite galaxies that orbit the Milky Way. There are dozens of smaller galaxies in our local group, and beyond our local group, there are billions of other galaxies throughout the observable universe. So what happens to our local neighborhood when Andromeda and the Milky Way merge? What happens to the other galaxies? What happens to the cosmic structure? The answer is, everything changes. The entire local environment is transformed. The merger of two galaxies is a significant event, but it's not a unique event. It's not an unusual occurrence in the universe. Galactic mergers happen throughout the cosmos all the time. Astronomers have observed many examples of galaxies that are currently merging. Some mergers involve two large galaxies like Andromeda and the Milky Way. Others involve a large galaxy and a small galaxy. When a large galaxy and a small galaxy merge, the small galaxy is typically consumed. It's torn apart by the larger galaxy's gravity. Its stars are scattered. Its structure is disrupted. It ceases to exist as an independent entity. It becomes part of the larger galaxy. This process is called galactic cannibalism, and it's quite common. Most large galaxies have grown by consuming smaller galaxies. The Milky Way itself has consumed numerous smaller galaxies. We have evidence of this. We can see tidal streams, long trails of stars that have been torn away from smaller galaxies that have been cannibalized by the Milky Way. Our galaxy is covered with the remains of its victims. This is shocking discovery number 44. Galactic cannibalism is a common process in the universe, and this might happen to our local neighborhood when Andromeda arrives. The Triangulum galaxy, which is relatively close to both the Milky Way and Andromeda, might be consumed by the merged galaxy. The Magellanic Clouds, which currently orbit the Milky Way, might be torn apart. The smaller galaxies in our local group might be scattered or consumed. Within a few billion years after the merger, our local neighborhood might look completely different. The local group might cease to exist as a coherent structure. The galaxies might scatter. The local region might transform into something entirely different. This is shocking discovery number 45. The entire structure of our local group will be transformed. But here's what's truly astonishing. This transformation is relatively minor in the context of the universe. Billions of galaxies merge every year throughout the universe. Galaxies are constantly colliding, merging, changing, being destroyed, being created. The universe is far more dynamic than it might appear from our quiet location in the Milky Way. We live in a relatively stable part of the galaxy. We live in a region that hasn't been heavily affected by major cosmic events in billions of years. But this is not typical. Many regions of the universe are far more violent, far more chaotic, far more dynamic. The universe is constantly changing. Galaxies are constantly transforming. The cosmos is alive with activity. This is shocking discovery number 46. Galactic mergers are common throughout the universe, and the cosmos is far more dynamic than most people realize. This also changes how we think about other civilizations. If civilizations are common in the universe, if intelligence arises frequently, then many civilizations have probably been destroyed by galactic collisions. Many civilizations have probably faced the kind of cosmic catastrophe that we're contemplating for Andromeda. Many civilizations have probably watched their galaxy be torn apart by a collision. Many civilizations have probably scrambled to survive. Many have probably failed. Many have probably succeeded by developing advanced technology. Many have probably spread throughout their galaxies and beyond. This is shocking discovery number 47. If civilizations are common, many have probably faced and survived galactic collisions. So we've explored what will happen when Andromeda arrives. We've looked at the timeline, we've examined the physics, we've considered the implications for our solar system, for Earth, for life, for civilization. We've looked at the simulations that predict what will happen. We've considered the transformation of our local galactic neighborhood. We've contemplated the dynamism of the cosmos. But there's one final question that remains. One question that's almost unanswerable but absolutely crucial. What should we do about it? We have 4.5 billion years before the collision happens. What should we do with that time? Should we worry? Should we prepare? Should we build something that will survive the collision? Should we leave Earth? Should we scatter throughout the universe? Should we build massive space habitats that can survive the gravitational violence of the merger? These are profound questions, and the answers depend on who you ask. Some people say we should focus on the problems of today. We should worry about climate change. We should worry about pollution. We should worry about war and poverty and disease. Andromeda is so far away, they say, that it's not worth thinking about. We should focus on immediate problems. We should focus on surviving the next century, the next 1,000 years, not the next 4.5 billion years. This is a reasonable perspective. It's focused on human timescales, on immediate concerns, on present-day problems. This is shocking discovery number 48. Some people argue we should ignore the distant threat and focus on immediate concerns. But other people argue differently. They say that humanity's purpose is to survive, to persist, to spread throughout the cosmos, to ensure that consciousness, intelligence, and life survive the inevitable catastrophes that the universe will throw at us. From this perspective, preparing for the Andromeda collision is important. It's a test of our commitment to long-term survival. It's a motivation to develop technology, to spread to other stars, to create civilization in multiple locations so that no single event can destroy us. This perspective looks at timescales of billions of years. It looks at the deep future. It asks, what must humanity do to survive not just the Andromeda collision, but all the other cosmic events that will happen after? This is shocking discovery number 49. Others argue we should prepare for long-term survival, even billions of years in the future. The truth, probably, is somewhere between these two perspectives. We should focus on solving immediate problems. Climate change is real, poverty is real, disease is real, war is real. These are problems we face today, and we should dedicate resources to solving them. We should dedicate our technology. We should dedicate our knowledge. We should dedicate our effort to solving these immediate problems. Because right now, 7.8 billion people live on Earth. Right now, we face challenges that could determine whether our species survives the next century. We need to solve these problems. We need to ensure that human civilization survives the immediate future, but we should also think about the long-term future. We should think about what kind of civilization we want to build. We should think about whether we want humanity to survive the Andromeda collision. We should think about whether we want life to continue on this planet. We should think about whether we want consciousness to persist in the universe. These are long-term questions. They don't require immediate action, but they deserve thought. They deserve consideration. They deserve to be part of our collective conversation about the future. This is shocking discovery number 50. The optimal approach probably involves balancing immediate concerns with long-term vision. One aspect of long-term planning could be the development of space travel technology. If humanity develops the ability to travel between stars, if we develop propulsion systems that can reach a significant fraction of light speed, then the Andromeda collision becomes less of an existential threat. We could leave the solar system before the collision happens. We could migrate to other star systems. We could escape the collision entirely. This is shocking discovery number 51. Advanced space travel technology could allow us to escape the Andromeda collision. Another aspect could be the development of artificial habitats. If we build massive space habitats, structures that don't depend on planets or stars, then the collision becomes less of a threat. We could survive in habitats independent of the galactic structure. We could weather the collision in our habitats. We could protect ourselves from the gravitational violence. This is shocking discovery number 52. Advanced habitat technology could allow us to survive the collision without leaving the solar system. Another aspect could be the development of knowledge preservation. If we build archives that preserve all of human knowledge, all of human culture, all of human achievement, then even if civilization is destroyed by the collision, the knowledge survives. Future civilizations could rebuild based on what we've learned. This is shocking discovery number 53. Knowledge preservation technology could allow human civilization to be rebuilt even after catastrophe. Right now, in this moment, as you're reading this, as you're contemplating these ideas, Andromeda is moving toward us. It's so distant that we can barely perceive its motion, but it's moving. It's approaching, it's unstoppable, and in 4.5 billion years it will arrive, the collision will happen, the universe will transform, everything we know will change, galaxies will merge, stars will be displaced, new stars will form, the night sky will be completely different. The structure of the cosmos, at least in our local region, will be fundamentally different. And we are the ones who know about it. We are the ones who can see it coming. We are the only creatures on Earth, at least as far as we know, who can understand what's happening. We are the only creatures who can appreciate the enormity of it. This is remarkable. This is astonishing. This is what makes us human. We look at the night sky. We see Andromeda. We recognize it as a separate galaxy. We understand that it's moving toward us. We can calculate when it will arrive. We can predict what will happen. We can understand the physics. We can comprehend the timescales. We can grasp the enormity of what's coming. And we can do all of this with our remarkable brains. Brains that evolved on a small planet orbiting a small star in a spiral galaxy. We are products of a long chain of evolutionary events. We are the result of billions of years of life on Earth. We are part of a cosmic story that stretches back to the Big Bang, and we are privileged to understand place in that story. This is shocking discovery number 54. We are the only known creatures in the universe that can comprehend cosmic timescales and cosmic events. Think about what this means. Think about the privilege of being human. Think about the privilege of being alive. Think about the privilege of being able to understand the cosmos. Most creatures on Earth live their entire lives without ever looking at the stars. They don't know what Andromeda is. They don't know that a galactic collision is coming. They don't have the intellectual capacity to understand these cosmic events. But we do. We humans have this remarkable ability. We have this extraordinary capacity. We can understand the universe. We can predict the future. We can comprehend the unimaginably large. We can grasp timescales of billions of years. We can imagine our galaxy merging with another. We can picture stars being ejected into the void. We can envision the transformation of the cosmos. And we can do all of this in our minds, just by thinking, just by using our remarkable brains. This is what consciousness is. This is what intelligence is. This is what makes us special. This is shocking discovery number 55. Human consciousness is a remarkable ability to understand the cosmos. And here's the final truth, the final insight, the final realization. The Andromeda collision is not something that should depress us. It's not something that should terrify us. It's something that should inspire us. It should make us appreciate the dynamic universe we live in. It should make us appreciate the incredible journey that the cosmos is on. It should make us appreciate the fact that we're here. We're alive. We're conscious. We're aware. We're able to understand what's happening. We're able to participate in the cosmic story. We're not just passive observers. We're not just bystanders. We're part of the cosmos. We're part of the universe. We're part of this incredible, dynamic, changing, evolving system. And that is beautiful. That is remarkable. That is worth celebrating. This is shocking discovery number 56. The Andromeda collision is a reminder of the beauty and dynamism of the universe. When you look up at the night sky and you see Andromeda, that fuzzy patch of light that's actually 1 trillion stars billions of miles away, remember this video. Remember what you've learned. Remember that galaxy is moving toward us. Remember that in 4.5 billion years it will arrive. Remember that when it does, everything will change. The night sky will be different. The structure of our galaxy will be different. Our world will be different. But remember that this is the nature of the universe. This is how the cosmos works. Galaxies collide. Stars merge. New galaxies are born, and consciousness, at least here on Earth, is able to observe it, able to understand it, able to appreciate it. This is the most astonishing fact. This is the most remarkable truth. This is what we should focus on. Not fear, but wonder. Not despair, but appreciation. Not dread, but awe. This is shocking discovery number 57. The most important thing about the Andromeda collision is what it tells us about the universe and our place in it. Two galaxies are moving toward each other, unstoppably, inevitably. One is ours. The other is Andromeda. In 4.5 billion years they will merge, new stars will form, planets will be scattered, the universe will transform. And somewhere, on a planet that might be completely different from Earth, some form of consciousness, perhaps human descendants, perhaps an entirely different species, perhaps an artificial intelligence we create today that continues to exist for billions of years, might look up at the night sky and see the light of these colliding galaxies. They might witness the greatest cosmic event of their time. They might see the birth of a new galaxy. They might be awed and amazed by the spectacle. They might look at the stars and realize, as we realize now, that they are part of something far greater than themselves. They are part of a cosmos that is alive, that is dynamic, that is constantly changing, and that is beautiful beyond words. The Andromeda collision is not the end of the universe. It's not the end of the story. It's just one chapter in an incredibly long book. The story will continue after the collision. New galaxies will form, new stars will ignite, new planets will circle new suns. The universe will continue on its journey. And somewhere in that universe, life will continue, consciousness will continue, wonder will continue. And the cosmos will remain the most astonishing, the most remarkable, the most beautiful thing we can possibly contemplate. This is what we should remember. This is what we should focus on. This is what should inspire us. Not fear of the Andromeda collision, but appreciation for the dynamic, evolving, beautiful cosmos we're part of. We are made of stardust, literally. The carbon in our bodies was created inside stars. The oxygen we breathe was created inside stars. The calcium in our bones was created inside stars. The iron in our blood was created inside stars. Everything that makes us alive was created by stellar processes. We are products of the cosmos. We are manifestations of cosmic processes. We are the universe becoming aware of itself. And that is the most profound realization we can have. This is shocking discovery number 58. We are made of and products of cosmic processes. And our galaxy, our home, will be transformed by this collision. Our galaxy will merge with another. Our sun might be ejected or rearranged. Earth might become a rogue planet or end up in an alien star system. Our entire world might be transformed. And that's okay. That's beautiful. That's the nature of the universe. We are living in a dynamic, changing, evolving cosmos. We are privileged to exist at this moment in cosmic time. We are privileged to understand what's happening. And that understanding should fill us not with fear, but with wonder. Not with despair, but with awe. Not with dread, but with appreciation. This is shocking discovery number 59. The Andromeda collision is beautiful despite being catastrophic. This is the ultimate message. This is the ultimate truth. This is the ultimate realization. We are alive in a universe that matters. We are conscious beings in a cosmos that is constantly transforming. And that is the greatest privilege imaginable, the greatest gift imaginable. To exist, to be aware, to understand, to contemplate the cosmos, to marvel at its beauty, to appreciate its dynamism. This is shocking discovery number 60. We should be grateful for the opportunity to exist and to understand the cosmos. The Andromeda collision is coming. In 4.5 billion years, it will happen. The galaxies will merge. The universe will transform. But that doesn't diminish the importance or beauty of what we're experiencing right now. Right now, in this moment, the universe is exactly as it should be. The stars are shining, the planets are in their orbits, life is flourishing, consciousness is emerging, wonder is filling our hearts. And that is enough, that is beautiful, that is worth celebrating.